All right, I'm gonna show you some string methods. So some of the things you can do with a string object. Okay, so here's a little program that scans two strings, this one, and then uses the double equals to compare them, which is going to be false because A and B are stored always in different memory locations. And then it uses the equals. This is the first method we're going to learn about, the equals method, to compare them. There's another video using the equals method in this playlist. You can watch that one too. Alright, so we can compile this and run it. Let me wait until it's compiled. There you go. Let's run it, and it's asking me for two strings, and that's how all of these are going to start. Two strings. So I'm going to put hello and hello. The first one's false because this comparison is always going to be false, and the second one compares the contents of the strings, and it's going to be true. Now if I run this and I put hello and hello all in caps, although it's the same word, the system doesn't know that, and the dot equals returns false because for the computer the lowercase e and lowercase and uppercase e are very different letters altogether. So the contents of these two strings are not the same. That's when there's another method called equals ignore case comes in handy. This will test whether the letters of two strings are the same, ignoring whether they're in uppercase or lowercase. So let's give this a try. I have hello here and then hello there. Equals ignore case returns true. Now there's another method that comes in very handy with strings, which is compare to. So compare to, notice that the first letter methods, the first letter is always lowercase, and then from then on is camel case. Compare to will tell me whether A is greater than or less than B. So for example, if I say, for example, alderman, which starts with an A, and zebra, which starts with a Z, alphabetically, alderman goes before zebra. And what happens is this. Alderman and zebra, if this returns a negative number, like negative 25, for example, any negative number, if this returns any negative number, it means that the first string, A, is less or goes before in the alphabet than B. Okay, so let's run it again. Let's run, I don't know, Iran, Iraq. Iran goes before in the alphabet because although they're the same up to the third letter, the fourth letter N goes before then Q in the alphabet. So alphabetically, this returns a negative number. Okay. If I do this again in the other way, so if I say zebra and fast food, zebra is later in the alphabet, right? And fast food should be earlier. In this case, I get a positive number. So A dot compared to B will result in a negative number if the string A should go before B in the alphabet. We say that the string A has a lesser value or smaller value than B. And it will return a positive number if the string A goes after the string B in the alphabet. Okay? Positive if A goes after B in the alphabet, meaning A has a larger value than B. Now the last case to see is what happens if they're the same, right? Well, guess what? It'll return 0. There it is, 0. Okay, because they shouldn't go not before nor after. The value of those strings when converted into numbers, it's the exact same. Okay, that's compared to. Now, another method of strings that can be interesting to look at is char at. Char at will return the character, the letter, at position whatever we give it. So char at 0 will return the first character. we will look at these positions here. Hello. Imagine the string hello. I'm just going to put it here for illustration purposes. If I have the string hello, the H is position 0. The E is position, I'm going to put it like this. Just for, the E is position 1. The L is position 2. The next L is at position 3. And the last L is at position 4. So, if I say A dot car at 0, that will mean the H. Okay? So let's look at this. Compile this. Run. And if I say hello, whoops, and then I need another string, hello, I get H, which is the first letter of character A. If I run this again and I enter hello and goodbye, this will print false because these two are not the same, and it will print H because I'm looking at the first character of the first string, not the second one. See, it prints H right there. 0. Now, the last character right there, we saw that it was 4. Okay, so let's compile this and run it and put hello there and whatever we want here. It doesn't matter, right? Because I'm only operating on the first string, which is hello. Whoops. So then here I hit enter and it gives me the O, which is the last character in the word hello. An interesting thing to notice, and this might happen in some of your programs, is I have character 4, right? What happens if I enter this, for example, sky? It doesn't have 4 letters. The program is working just fine. Whoops. Something happened. Something really bad happened. I get this thing that says exception in thread main. String index out of bounds. Basically, this index 4 is out of bounds because the word sky doesn't have a fourth doesn't have not even a third nor a fourth position. Remember, character 4 means the 5th character because we start at 0. So it says the string index is out of bounds. Okay, and it gives us an exception. This is called a runtime error. This is an error that the computer couldn't detect when it compiled because it didn't know what we were going to put here. Okay, but it detects it when the program is actually running. But caret will return the string, the character at whatever position. This returns the primitive type character. Okay, so we can have something like this: car C equals A dot car at 4, and car D equals B dot car at 0, for example. Okay, and then we can actually compare these two. We can see C equals D. Okay, so what we're doing here is we're going to get the 5th character of A, and then we're going to put in variable D, we're going to put the first character of the string B, and then we're going to compare the 5th of string A with the 1st of string B. Think about what we're doing for a second, and then hit play again. All right, let's try this. So if I'm running this and I say hello, whoops, wrong place to do hello. C equals D. Sorry about this. C equals D. I'm fixing my program. Okay, so I will input hello here, and then hello here again. I'm going to get false because the 5th letter of hello is O, and the first letter of the second string, which was also hello, is H, capital H. However, if we run it, if we run it again, and we say hello, and then we say oh my, the 5th letter of hello is the same one as the first letter of oh my, right? So it returns true. This returns true. Remember, this returns true only because we're comparing a primitive type the character primitive type. If we were comparing the strings, this would always be false because strings are pointers of memory. And then the last method I want to show you, at least for now, is the method contains. So let's erase all this. We can print, for example, whether the string A that contains the word he. Okay? So let's compile this. It's going to ask me for two strings, but we're only going to operate on the first one. So here I'll print hello, and the second string we don't care. Now hello contains he right here, right? Hello contains he, so this returns true. If we run it again, and I say hello He-Man, right? That contains the word he twice, so it's definitely going to say true. Let's run it again and say I love thee, and then something else. Here, here there's the word he, but we're looking for he starting with a capital letter. Okay? That's why this returned false over here. So let's look for lowercase he and run it, and then I'm going to say I love thee. Right? Here's the word he right there. Okay? Here's the string he. That's what we're looking for. Two letters he together in the string. It's not actually a word. I love thee, whatever, this is the second word, we don't care. And it'll return true because it found he. Okay? Now we can do something tricky, and this will end this. We can do whether the string A contains the string B. So for example, we could use strings like this. So for example, we run this one, and we'll see I own my MTV, and we'll see, well, does this contain my, the word, or the string my? And it does, right? I can run it again, and I can say money for nothing. Does it contain money with a lowercase m? No, it doesn't. It contains money with an uppercase m. So contains is an important string method. Compared to get the alphabetical order of the strings is a very important method. Equals and equals ignore case are very important methods, and char at is a very handy method to compare like parts of a string or to access parts of the string.